So today, I'm going to continue to finish up the chapter 7, the array lists and the classes and array lists. Okay. So in general, when we use the array list, as I mentioned, that the array list can be created for a reference variables and for reference type. So the Arraylist Adt, the Adt basically stand for abstract data type. So in Java, there's something called Java Collection Framework. The Java Collection Frameworks defines interfaces and classes for common Adt, known as collections in Java. Because, for example, so Java actually put the, all these interfaces and classes into a group, we call Adt, and that's called a collection. And a collection represents a generic group of objects we call element. So for example, like array list, we create a list of elements. Each element is an object, is a reference variable. Okay, so and we call this a collection. And then we can define some common methods to manipulate these elements. Okay, so the list interface is one of the most commonly used collection types. Okay, so we use array list to create a list. We can create a list interface. Okay, so now the syntax for the array list is this. We can say array list and T. Okay, we use a general a character T to represent any kind of object or class or object. So now this is actually the reference variable, which is particular array list, and then that's the syntax. So we can replace T with any. So basically, we can replace T with any actually object type. So we can replace T with, like, if we want to represent a list of integer, you can replace T with integer, which is a wrapper class of integer, right? So so you can actually replace this, and also you can replace this with a class like a bank account. So you can replace with any kind of reference type as far as it's not primitive. So, and then once you declare these, list for these elements of a T type, like an integer type or bank account type, and then we can actually use the methods to manipulate these objects. Okay. So now these are the methods basically we can use to manipulate these group of objects, which is of T type. So you can say use get, set, size is empty. So if we remember in the example of array size, array list for integer types or bank account type, so we can actually use these to manipulate, to add any more object into the list or remove some of the object from the list. So we can always do this. So for example, if we create a software for a bank, so we can actually create an array list of bank account. So we can add one particular bank account into the list, and we can remove it from the list. Okay. So these are the methods we can use. For example, if we declare a tin num as integer type, right? So we can array list. Integer. So that's just a one line. So tin num is an array list of integer type. And then you can basically call any method. Assign elements 3, 3's value 11. Okay. So basically, this is going to actually, get, this is an index. Okay. So that's element 3's value to x. So that means, so tin number, which is, if the tin number is a list of like 5, 6, 10, 11, something like this, and then this is index 0, index 1, index 2, index 3. So if gets 3, teams numbers that get 3 basically going to actually return a value 11 and assign to x. Okay, so this is actually the method called get. And you can also set. So you can actually say set, and this is going to actually tin number set, basically going to set the value in the index 0 from whatever the current value into 25. So you can change the value in the index 0. So these are various different variables. So one of the actual methods like is empty. So you can say tin nums is empty. Basically just verify whether tin num is an empty list or not. Okay, and this size basically just return the size of the array list. Okay, the tin num list. Okay, so the tin num size, if the size is 5, and then the tin num dot size parenthesis is 5, which is greater than 0, then in this case, this condition is true. So we can define these array list. It's called ADT method. ADT method basically means these methods are defined for any type of array list T, whether T is an integer or double or bank account or a, a class called like a student. Okay, so you can represent any objects as far as it represents a reference variable, not primitive. So then you can always use these methods to manipulate. And there are some more methods like clear, add, and remove. So you can remove a method from an array list. Okay, there are two actually overloading approach. So you can actually remove the current element, which is not, I'm sorry, you can remove element, the first occurrence of the element which refers to the same object. Okay, And also you can remove a certain element with an index. So you can always remove an element out of the array list, either by comparing the reference value, or by checking the index. Okay, so once you say teens num dot remove 1, that means you're going to remove the element at the index 1. So you can just remove the element in the index 1. Okay. So these are called array ADT methods. So if these methods basically works for all array list type. Okay. Now the next thing we're going to talk about, I will briefly talk about, is the Java documentation for classes. Remember that you can actually create the Java code, and you can always put the comments, right? Put the comments in there. So typically there are two ways. There are two ways you can put the comments in there. One is if you want to put the comment in one line, then you can put / twice, and then you can put whatever the comments you say. For example, before a method definition, say, okay, this is a method. Okay, this method is to do whatever, blah blah blah. Okay, so everything actually in this line after this / double / the comment is a comment, which means the Java compiler going to choose to ignore it. Okay, so the comments is basically it's written for the user to read it. If you read the code, and if there's a comment in there, so that means it's just for you. Make sure you can better understand the code. Okay. Now the other approach, the other comment is you can use / asterisk, and then you can type your comment. This method is blah blah blah, and then you can put another asterisk / so you can have a / asterisk / and everything in between are the comments. Now the difference is this double / is basically used only to create a comment for one line, but use / asterisk and asterisk / you can actually put the comment across the lines. So you can put a couple of lines of comments. So the / could be in here, and the backward, the closing part could be in here. So this is a method to do something, blah blah blah, and then at the very end you can put another one. So anything between / asterisk and asterisk / are the comments. It could be across the lines. You can have a multiple lines. So this is actually more flexible. Okay, but this is very compact, very simple. If you actually put some kind of assignment, say x equals 20 semicolon, and then you can put the comments after the assignment, just to give you some kind of idea. What does this assignment supposed to do? Just give the user some kind of idea. Okay, so this is a comment, which is kind of good. And however, Java actually does more than just putting the comments. Java actually it's some kind of a tool to manipulate the comments, and these are called Javadoc. The Javadoc tool passes source code along with specifically formatted comments to generate a document, which is kind of cool, right? So when people actually try to read the code. So typically the code is the comments is actually distributed all over the places. In any place, people feel like I would like to put the comments in there to make sure people can understand why I put this piece of code over here. So they want to put the comments in there. That's fine. However, in Java, so they create some kind of a tool that allow people to, before they read the source code, because when you read the comment, you have to read the code, right? Because the comments actually are embedded in the code. So if you say, I don't want to read the code, I just want to generally read the comments about what this piece of code is supposed to do. So if I try to read actually the source code, like a bank account.java, so you have to open the bank account.java and read the code. And then if there's a comment, then you read the comments to better understand the code. But sometimes, for some people, they don't want to read the code. They just want to get a general overview of this code. So what this class is supposed to do. I don't want to know the details of how this class is implemented, but I just want to know what this class is supposed to do. So normally, people put the comments at the beginning of each of the class or at the beginning of each of the methods in the class. Just tell other people what this method is supposed to do. Now, the method you may actually spend like 100 lines to implement a method. People don't want to read the method. They just want to know what this method is supposed to do. So normally they put some kind of summary at the beginning of the method definition. So now Javadoc allows people to create the comments. And if you follow certain kind of syntax for your comments, and then Javadoc can eventually, generate a documentation. Okay. They're going to pull all these comments out and create a document. So allow people to read that document, then to understand what this class is supposed to do before they even actually open the class, open this particular class and read the source code for the class. They don't have to. They just use the Javadoc tool to generate, pull all the document out and just read the document. Now, in order for the Java to do that, then when you put these comments, you have to follow some kind of syntax. Okay. So the Javadoc tool passes the source code along with the specifically formatted comments. So the comments has to be formatted to certain format. Okay. To generate the document. The document generated by Javadoc is known as API for classes and the classes methods. Okay. So you can actually put the comments before the class definition, or you can put the comments before each of the methods, okay, or each of the fields. When you declare a field in a class, okay, then you can put the comments and following the certain follow certain format, okay. So these specially formatted comments for Javadoc are called doc comments. The doc comments will be picked up by the Javadoc tool and create a dedicated documents. Okay. So then people can read the documents instead of actually open the source code and read the code and then read the comments in the code. You don't have to because they can pull the comments out and create a documentation. Okay. Now, what is the format you have to follow? Which that allows the Javadoc to generate these documentation. Okay, here you have to follow this format. So in the Javadoc, you have to use the, you have to put your comments between / asterisk asterisk, and then asterisk /. That's slightly different than the comment, right? Because when you talk about a comment, you just say, okay, I just put a / asterisk and the asterisk / and everything in between is a comment. But that comment is not the format that Javadoc can pick. Now, if you want the Javadoc to pick up your comments, you have to put the double asterisk here and a single asterisk at the end. And that kind of format is, is that basically meet the syntax of this Javadoc tool. Okay, so that's just one thing. So you have to, so the Javadoc comments, which is a multi-line comment consisting of all text enclosed between / double asterisk and asterisk /. Okay, so that's important. You have to follow this. Now, in order to understand how you can actually put the doc, then let me actually just pull out the examples we just worked on. Okay, let's just pull out the example we worked on in the bank account. Okay, remember the bank account we just worked on? Okay, bank account. Okay, so this is actually the bank account the code. So we define a class, which is a bank account, and we have a couple of field over here, and also we have some of the constructors, right, to create the bank account, and we have some of the methods: deposit, withdraw, and also transfer, and we have some of the method called get balance, and these are called, what are these called? These are called getter, right? Some kind of a getter or accessor, and getter, and these are called setter or mutator, right? So these are different methods, and this is the main methods defined in the bank account, which is a static method. So that's something we can talk about a little bit later. Okay, the static method basically defines the method which does not belong to the class. Okay, it's not a member method of the class. It's actually independent of the class. Okay, now in order to illustrate this, I can actually tell you that we can even actually take the main method away out of this bank account and create another class. So the other class, we can actually put the main method in another class and call this bank account class. Okay, so let's do this. Let's quickly do this. So let's just copy and copy. So that's the main method. So what I'm gonna do is I'm gonna copy. Oh, highlight. Okay, so I'm gonna cut. Okay, so what I do is I'm gonna create another file I called my bank account main method or main, my bank account main dot Java. Okay. So then I copy this piece of code over here. Okay. And then for the first line, I'm going to define a public class, and I'm going to use the same name as the file name, my bank account main, right? I define this class over here. Okay. So I just put the main method in another class. Okay. Now, of course, I need to copy this import util array list as well. So I can just cut over here and paste over here. So I can actually just move do the indentation to make the code a little bit better. Okay. Okay. So let me just do the indentation. Yeah, that's it. Okay. So this is actually the, now I basically put the two actually code. One is okay. So now I can actually run this code again. So Java, but because the main method is now in another class called my bank account main.java. So that's why I only compile the class with the main method. So my main account, my bank account main.java. Okay. So then I can run this code. So I can do this, right? Okay. So I can say the owner of the first account is Brady Chen, John Doe. So I can do this. Okay. Now, the next thing I want to do is I want to do I want to put the comments in there. Okay. So first, I want to put the comment in the class called the bank account. So what I can do is I can put the comments for the Java doc. So then I can say this, right? You can put it's the same as just like any other comments. This class represents a bank with a bank account that has a balance. Okay. Let me, so I can change the line. Okay. It has a bank account, balance, and can be changed by deposit and withdraw. Okay. I can put the asterisk, and then I can use one of the also part of the syntax. I can say at author Brady Chen, and also asterisk at version 1.0. So you can always put the version 1.0 initially, and then you can close this. You can close this comment. Okay. So now I create a Javadoc, comment. So which basically follow these syntax. So I use the / double asterisk and then end with asterisk / and then I can have something in between. And also you in certain place you can put the actually at like author at version. So this is basically the another part of the syntax defined by Javadoc. We're going to explain this a little bit later. Okay, so now this is for the class. Okay, now for each of the field, instead of using general comments, I use say I put the fields here, right? But that's just a general comment. It's not a Javadoc comment. So if I want to do this, I can put the Javadoc comment here, and I can say the field, the following field actually defines what and what. You can put the explanation for each of the field. Okay, say balance. That's basically this is actually the, what can I say? It's a do whatever. So you can actually continue with this, and I can actually close it. I should also define the other account owner, account ID, something like this, right? So, but just let you know this is how you're going to create this Javadoc. Okay. For each method, you can also create a Javadoc, like a constructor. You can create Javadoc for the constructor. So I say this is a default constructor. Which assign to 0 and account to right? Okay. And then you can create the other, So if you use this syntax, then you are actually following the Javadoc syntax. Okay. So this is how you're going to create a Javadoc for each of the program. So now, so in the Javadoc, so in the Javadoc comment, you can always put some of the comment block tag. It's called a block tag in Javadoc comments. One of the block tag is author. The other one's version, prom, which is basically means parameters. So if you actually create a Javadoc for a method or constructors, if the constructor has a parameters, then you can describe each of the parameters. Because when you actually describe the command, you can say, okay, this parameter basically the author is supposed to enter the bank owner's name, a bank account ID. So you can actually make sure that when people actually call this method, they put the right arguments in there. Okay. And this is a return. Also just say this method is going to return the value. What kind of value is returned? Okay. And also, if you say, okay, in order to better understand this method or anything, you can put another tag called C, at C, S-E-E. C basically means, okay, to better understand this method, please also see, you can refer the reader to other actually relevant websites or class members. So you can actually refer to the other area which allow them to better understand this particular method. Okay, so that's basically the C. So this is actually the common block tags in the Javadoc comments. The bottom line is for Java, in order to actually the Java actual compiler to recognize this is Javadoc comments, you have to put a / double asterisk. And then at the very end, put a single asterisk / Okay, so this is actually the Javadoc. And now let's go back to these. Let's go back to this bank account. Say, for example, you can say, okay, I can copy paste this Javadoc, and this is not a default constructor. This is a constructor which allows the user to create a bank account, and see, this is a constructor which allows the user to create a bank account with an owner. Okay, and then you can put something like Ram. So that's the owner. You can say bank account owner. Okay. Okay. Now, if the method is created by someone else, and you can also put the author name. Sometimes, in the class, this method is created by Brady Chen. The other method is created by someone else. You can also use the author tag at author, and you put a different author. So it's up to you. Bank account owner of string type. You have to enter as a string, right? for this. So you can put the information over here, and then this is another constructor which allows the user to create a bank account with initial balance and the account owner's name. And then the parameter, you have two parameters, owner and init amount. Init amount is the balance. When people create an account, they put the initial amount of money in there. So this is actually the the Javadoc you can use in each part of the class definition. So then now people can use the Javadoc tool to pull all the actually comments information, the Javadoc comments, and create a dedicated document. So now people just simply read the document to understand without actually reading the code to understand what the particular actually class supposed to do. Okay, that's basically the idea of Javadoc. This is a very powerful tool. Okay, if you read the Zybook, 7.16 is actually I'm going to skip this, but you don't have to skip that part because you should not skip that part because there's a lot of exercises in there. But there's no much topics we can cover in that part. It's just basically the exercises, examples. Okay. Now, the next topic we want to cover is the statical fields and the methods. Okay. Actually, we have used the statical methods, and we also define a method without the keyword called a statical, right? So like these are called member methods. So if any variable, a field variable in the class, there's a statical keyword, that means it's a statical variable. If the method has a statical keyword, it's a statical method. And what does statical mean? The keyword statical indicates a variable is allocated in memory only once during the program execution. Okay, so statical field is a field that the class field of the class instead of field of each class object. Okay, so now we haven't actually used the statical field yet, but we have used the statical method, right? Statical member method is a class method that is independent of class object. Okay, now main method is a statical method. So it really doesn't matter if your program contains a couple of different classes, like a bank account. I just split the bank account into one class into two classes, and one class is called a bank account. So the bank account basically defines a bank account object, so which contains like account balance, account owner, and account ID. And we have a whole bunch of methods like a deposit, withdraw defined for the bank account. Now the main method is basically the entry point for people to start to run the program. So when people actually start to run this program, main method is the starting point. A main method does not belong to this bank account object. It basically belongs to the whole program. So it really doesn't matter where you put the main method. So that's the reason why I actually, split the bank account and pull the main method out into another class called my bank account main. So that means that's the main entry point for my program. Okay, so when I compile the program, the whole program, I compile Java C and then my bank account main.java. So I compile this and it's gonna run. So now this statical method is a class method that's independent of a class object. Statical method methods are typically used to access and mutate private static field from outside the class. Okay. So because it's independent of class object, that this parameter is not passed to static member method. Okay. So that means if I define a static method, like let me actually go back to the example. Okay. So here's the bank account. Okay. So then in here, for any method like a deposit, okay, I can, because this deposit is a method, there's no statical, right? No statical keyword. So that means deposit is a member method. Deposit is a member method. As a member method, I can access the member field variable, like a balance. So balance is defined here, right? In the bank account. So balance is a member, a variable. It's a member variable. It's a field variable of a bank account. So the member method can access the balance. Okay, balance. Or I can use this dot balance. It doesn't matter. It's the same. However, in the main method, which is statical, right? The main method, I cannot say balance equals 12. Cannot do this. If I do this, read it carefully. I put this balance equals 12 at the 17, line 17. Now if I compile this code, it will give you error message. Don't be surprised. So at the line 17, arrow cannot find the symbol. Balance equals 12. It just points to the balance. Say, I cannot find the balance because main method is a statical method. It's not a member method. So you cannot access any field variable defined in the bank account. Okay. So if you want to do this, you have to use, okay, to access the balance, you have to use the object. So the balance actually belongs to each particular object. For example, I have to erase this one. So if I want to access the balance, so I have to, the balance is associated with each individual account, like my checking account, my savings account. And then my checking account has a balance. My savings account has a balance. Okay, so balance is associated with each individual account, not associated with the general bank account. Bank account has a balance in general, but each individual balance should be associated with account. So in that case, if I want to access the account, then you have to call the individual one. For example, you have to call, say, okay, my checking account. Now, if you type, say, my checking account dot balance, that makes some sense, but it's still not correct. Okay. Now, you got an error message again, but for different reason. It's not because balance is not this balance. The my checking account doesn't have a balance. It has a balance, but the balance in my defined in the bank account is a private. It's a private variable. So when I could call my checking account, and the main method is regarded as outside class. So from outside the class, I cannot directly access the private variable balance. So that's the reason why. So when I compile it, its error say balance has a private access in bank account. So it means the Java compiler admit that the my check account has a balance. My check account dot balance makes sense, but you cannot access it. Why? Because it's a private member. Now, in order to access the private member, you have to use the public methods to access it, like a getter, right? Or setter. Okay. So then if you want to actually change the balance, you can say set account balance. Do I have a method called set account balance? Yeah, I can. Okay, I don't have a method called set account balance, but I do have a deposit. So that means I cannot randomly set the balance value. All I can do is I can deposit the value. So that means I can only add dollar amount into the existing balance, which makes sense, right? Because once you create the balance, a bank account, and your balance should not be randomly set by anyone. Other people can, you can put the dollar amount into your account and deposit the money into the bank account. So that means you have to add dollar amount into the balance. You cannot randomly wipe out the current balance and then set up your own. So which makes sense. So what I can do is, if I want to manipulate the balance, I can use the function called deposit. And then I can actually change the balance of this. So from here, you know that because balance is a member variable, it's a field variable. So you cannot directly access the balance from the statical method, because statical method is not part of the object method. It's not a part of the member method. Okay, just let you know that. So this is why static field and methods, they are very important. If once you see a static method, then that means this method does not belong to the bank account object. Okay. And also the static field. Sometimes people actually want to define a static field. The static field basically means it's a not member field, but it's basically a field that used to describe the class itself. Okay. So that means this basically, the static field is basically used to describe the class itself. In another word, so that means all the member object. So like, for example, if I just define a static field for the bank account, that's the field that associated with the bank account, not individual account. But that means all the individual accounts should also have that value. Okay. So that's the difference between static field and member methods. Okay. So so we can actually, I'm not going to actually give you at this moment, I'm not going to actually particularly give you a particular example for the statical fields and the methods. But when I work on any of the examples, I will actually point out what does statical fields and the statical method means in my other examples. Okay, so that's basically all we want to talk about for chapter 7. Okay, chapter 7. So we're done with the chapter 7. So if you have any questions on chapter 7, please let me know. Okay. Now, do you have any questions so far? Now, again, please, if you haven't done any of, do your assignment for each of the chapters or labs, please let me know. Even though many of the assignment has passed the due date, but in this class, you can always, make up with your missing assignments. Okay, so please check the syllabus for the detailed information. You may get some penalty for this, but it's still, I encourage you to complete any missing assignments. Okay. Now, chapter 7 is about object and the classes. Now, chapter 10, so as I mentioned, I'm going to skip, from chapter 7, directly skip the 8 and the 9 to chapter 10. So we will, if we have time, we will come back and talk about the 8 and the 9. But right now, I think the next topic we're going to talk about is chapter 10. Okay. Now, chapter 10 is called Derived Class. Okay. The reason why I want to, skip to directly jump to chapter 10 is that's the main part of the Java. So when we define a class, when we define a class, basically in Java, we define a group of objects with the same characteristics. Okay. So each of the objects is a different object. However, these object has the same characteristics. For example, if you define a class called a bank account, so then we describe the general attribute for the bank account. So we're going to say, oh, a bank account should have account balance. A bank account should have account owner. A bank account should have account ID. Okay. Or maybe some other attributes. But these three are basically very important attributes. Now, however, when we talk about the bank account class, the purpose for the bank account class is to define an individual bank account. It's called a variable, a bank account variable or bank account object. Okay. So then we want to actually discuss an individual bank account, like my checking account, Brady's savings account, John's checking account, and your account and my account. You want to talk about various different accounts. Now, each of this account should have the balance, and it should have a value for the balance, and each of the accounts should have the value for the owner. So that's what we're going to talk about. Okay. Now, for derived class, we basically want to define a class that is derived from another class. Okay. So we want to talk about a class which is derived from another class. Okay. Now, this class is called a base class. This another class is called a base class. The derived class is called a subclass. Okay. Now, why we want to do this? I will give you an example. But now, let's say divided class is said to inherit the properties of the base class. This is a concept called inheritance. Okay. Now, let me give you an example. Let's say, suppose I have a class called a person. I define a class called a person. Now we can define certain kind of field variables for person, right? What kind of variables we should define for the person? Name, right? Or to make it more specific, you can say last name, first name. Okay, I call the L name, first name, F name. What other field should I define for a person?
Gender.
Gender. Age, right? Now I basically ignore the type. Okay, so L name should be string type, right? Basically, you can define as string type. String type. A gender, you can also put a string type. Say either it's a M or F. Age should be integer, right? And then a person should have, let's say SS number if he or she is living in the United States. An SS number, I can either use I can also use a string, right? Because even though it's a number, but you're never going to use this number to do addition or multiplication, right? It's just a number. Okay, it's just it's kind of an ID. It represents your ID. Okay. Honestly, you can find many field variables for the person. You can say, okay, phone number, address, um, what else? A blood type, right? What is a blood type? And so you can define many different um, uh, field variables for the person. Now, the question is, in your particular applications, when you do the program, do you want to put all the field variables in there? The answer is no, right? Now, depend on what type of application you want to work on. So if you say you want to do the coding, you want to do the program for division of a motor vehicle, it's a, and then you need to include the field variable as last name, first name, gender, age, or maybe like ethnic group, which ethnic group you belong to, right? Or your driver's license ID, because that's what DMV actually interested in. Okay, or your blood type. That's probably important because when you actually involved in a car accident, now if you can actually, if people can immediately find your blood type, that will be very helpful for the emergency people, right? So you want to include all the actual field variables that are related to the applications you're working on. Okay, you don't have to put all these variables. Okay, so that's one example. The other example, if you want to actually create a class called a person, but you're going to work on the program that try to do the coding for a biological lab. So in that case, maybe blood type is important. The driver's license is not that important, right? Because why the biological lab want the information about driver's license, right? So that's the thought. So you can include. Now, the derived class is basically, so in some case, you say person, but you want to create a particular group of persons. Okay, so for example, like I want to create a class called a student. Okay, and then you're going to say, well, what are the field variables for the students? You're going to say, oh, last name, first name, gender, age, social security numbers. These should be in the field variable as a student for the student. And however, a student actually, besides all these variables, students should have particular variables. Okay, now these variables like a student major, student GPA, these are a particular variables that they're only actually used in student, right? However, student also use all the variables over here. So in that case, we can actually define, say, student. We can define student as derived class as a person. So that means I can use part of the information divided in person. Now the relationship between person and the student is student is a person, right? That's a relationship. A person may not be a student, but a student is a person. So that means all the attributes, all the fields variable defined for person also applies to the students. But a student has some specific variables, field variables, that does not apply to person. So in that case, I can call student a derived class of person. Okay. Now I'm going to stop right here because we're running out of time. But that's basically defines the base class and the derived class. Now the derived class is a base class, but the base class is not necessarily a derived class. Now that relationship can be seen from this person and the student relationship. So person can be, you can define class called a person, and you can define class called a student. But student is a person, but a person is not necessarily a student. So then you can define student as a derived class of person. Okay, so we're going to continue next time on Friday. So we still have a class on Friday, and the test is going to be actually available from 12 to actually 12. Okay, you're going to have 12 hours to work on your test. So, okay, I think that's pretty much all for today. So I'll see you on Friday.
See you on Friday. Have a good day.
Bye.
Thank you very much. Have a good one.
Yeah.
Have a good day, Professor.